Hey, it's Mr. E here, and our aim for this video is how do we solve trigonometric equations? Okay, so as a warm-up, I want you to find the exact value of the cosine of 45 degrees and the cosine of 315 degrees. Pause the video and do that. Okay, so the cosine of 45 degrees, you might have memorized it by now. It's radical 2 over 2. To find the cosine of 315 degrees, I'm going to need to sketch the angle and use the reference angle to get that. So let's sketch the angle, 315 degrees. There is the initial side, and the terminal sides should be about there. So this is my 315 degree angle. 315 degree angle, excuse me. Okay, now I have to find the reference angle. The reference angle is 45 degrees. So I'm going to use the reference angle to find the cosine of 315 degrees. What's the cosine of 45 degrees? Well, I found that already. It's radical 2 over 2. Now, all I have to worry about is if cosine is positive or negative in this quadrant in which the reference angle is located in. As it turns out, cosine is positive in this quadrant, quadrant 4. So the cosine of 315 is the exact same thing as the cosine of 45 degrees. Same value, same sign. When I say sign, I mean positive. So they're both positive radical 2 over 2. So what do you notice about the exact value of the cosine of 45 degrees and the cosine of 315 degrees? Well, we just said it. It's the same value for both. They're both positive radical 2 over 2. Why do you think this happens? Well, the reason why this happens is because 315 degrees has a reference angle of 45 degrees, and it's also located in a quadrant in which cosine is positive. So there you go. That's why it's got the same value as cosine of 45 degrees. Same reference angle, and then it's also located in a quadrant in which the cosine is also positive. So what's the point of this activity? The point of this activity, so here it is to get you to see that trigonometric values are not exclusive to one angle. What do I mean by that? Here's what I mean. 45 degrees is not the only angle with a cosine of radical 2 over 2. 315 also has a cosine of radical 2 over 2. That's what I mean when I say trigonometric values are not exclusive to one angle. In fact, there are other angles. If we kept on going around and around and around, and then we could go in a clockwise fashion, we're gonna find an infinite amount of angles that also have a cosine of radical 2 over 2. So that's the point of this activity, to get you to see that trigonometric values are not exclusive to one angle. Okay, keep that in mind, because that concept is gonna come up again during our course of solving trigonometric equations. Okay, so here's our first example. Solve for x if x is greater than 0 and less than 360. If x is greater than or equal to 0, and less than or equal to 360. Okay, so here's a trigonometric equation. You have to treat it like a regular equation, so that means we're going to isolate the variable. So we're going to add 1 to both sides. That's the opposite of subtraction. And we get 2 sine x equals 1. Now we're going to do the opposite of multiplication here. That's division. This is going to cancel out. We're going to get sine of x equals 1 over 2. Now we have to do the opposite of sine. The opposite of sine is sine to the negative 1. And we're going to do that for 1/2. And that's going to give us one of the values of x. So let's get our calculator out. Make sure you're in degree mode. So second sine, that gets us sine to the negative 1 of 1/2 is going to be 30 degrees. So 30 degrees is equal to x. Now look, that's not the only value of x. There are other values of x that have a sine of 1/2. We just have to find them. So we're only halfway done, okay? How do we find the other angle that has a sine of 1/2? Well, I'm glad you asked, and let me show you. We're going to use this 30-degree angle here that we got. We're going to use that as a reference angle to find the other angle. Okay, so here's the thing, all right? Sine is positive here. Do you notice that? This 1/2 is positive. So I can immediately eliminate this quadrant and this quadrant, because in these quadrants sine is negative. So I'm going to take that 30-degree angle and I'm going to sketch it in this quadrant here, because in this quadrant sine is also positive. So now, what's the measure of this angle here? That's going to be my other x value. Measure of this angle here is 150 degrees. So the other value of x is 150 degrees. So those are my two values of x. And you can test it out. Type in sine of 150 and you're going to see that you get 1/2. See? Alright, so basically what you do is you're going to solve the equation. You know, you're trying to isolate the variable. And you're going to find one of the values of x. And that's how we got that 30. Then you're going to use that 30. You're going to use this to sketch the reference angle of the angle that you're looking for. Alright? Let's try another one. Solve for x. If x is greater than or equal to 0 but less than 360 degrees. So let's go ahead and isolate the variable. So plus 2 radical 3 plus 2 radical 3. We get 2 tan x equals 2 radical 3. Divide both sides by 2. 2's cancel out, and I get tan of x equals, the 2's cancel out here, radical 3. So I'm going to do inverse tan to get one of the values of x. Excuse me, that should say radical 3. So let's go ahead and do that. So second tan, all right, because you're doing the opposite of tan here. Radical 3. And we get 60 degrees. So one of the values of x is 60 degrees. Now we got to find the other one. So we're going to use this as a reference angle. All right? The quadrant I sketch it in depends on whether tan is positive or negative. So as you can see here, tan is positive. So in which quadrants is tan positive? Well, it's positive in this quadrant, but we got that one already. That's the 60-degree angle, right? That's this angle here that we found already. So that's done. We used that quadrant up already. In this quadrant here, tan is negative, so that's no good. We're looking for the quadrants in which tan is positive. This quadrant here, tan is positive. And this quadrant here, tan is negative. So I know that I'm going to sketch a reference angle here of 60 degrees. So to get the whole thing, I just find the angle in standard position that has that terminal side, the same terminal side as that reference angle. And what's that? That's going to be 180 plus 60, which is 240. So x is equal to 240 degrees. Those are my answers. And again, I can test it out this way. The tan of 240 should be radical 3. And it is. Because that decimal there, that's radical 3. Here, I'll show you in case you don't trust me. See? There it is. Okay, now it's your turn to try it. Here's an equation, and I want you to solve for x. If x is greater than 0, greater than or equal to 0, and less than or equal to 360. Hope this video helps. Take care.